Welcome to your online geometry class. In this first section we're going to be learning a little bit about some geometric definitions that will help us throughout the rest of this course. So let's begin by first looking at the first definition they'd like us to try to define. The first one is a point. A point is a geometric object that has no width, no height, no length, and it's usually just used to describe a location. So I want to kind of make sure we talk about it. It's an undefined term, but if you think about it, a point we usually draw as some sort of sphere or dot, but really it's supposed to be infinitely small in every direction. So if you think about it, it would go all the way down to nothing and just describe a single point and location. So it honestly would be not visible, so we draw it a little bit bigger so that we can see it. Commonly, we'll sometimes plot it on a graph, like if we were going to plot the point negative 2.8 comma 4.6, we'd go left 2.8 and then up 4.6, and that represents a point in space, but it's not supposed to have any width, length, or depth to it. So it's supposed to be infinitely small and just a pinpoint location. Or maybe we could even look at it in terms of 3D. This is a 3D graph system, and commonly with a 3D graph system, x comes out towards you, y is where x usually is, and z goes up. So we can actually plot a 3D point of 2.5, 3.6, and 4.8 in 3D space. So you can see the point would be coming down the x-axis, then going right on the y-axis, and then up to its final location on the z-axis, so it'd be out in space. Again, it's not really supposed to have any width, depth, or height. It's supposed to be infinitely small, and it's just a point out there in the space. You can see I can kind of rotate that so you can see that it's in 3D. Alright, so a point, you kind of have an idea. It's a pinpoint little distance of a location. It's the best way to describe it. It has no height, no width, and no length, so it's infinitely small. Alright, the next term we're going to look at is a line. It's a straight geometric object that extends infinitely in opposite directions without any width or thickness. So let's kind of go back to what we have an idea of what we think lines look like. Commonly we'll graph them on a Cartesian coordinate system, and so if I were to graph the line y equals negative 2x plus 1.5, we'd start at 1.5 and go down 2 and over 1, down 2 and over 1. You can see we kind of get a graph that looks something like this. So a line, again, it's supposed to be infinitely thin, and so it would kind of almost disappear again, but we draw it a little bit bigger so that we can see it, and it's a set of points going in two opposite directions. We could also consider this again in the 3D idea. We could plot a line in 3D space, and I guess those lines would go right through those different coordinate systems, the x-axis, the y-axis plane, and then it comes down here. So it gives you an idea of what a line is commonly described as. It's a straight geometric object that extends to infinity in opposite directions without any width or thickness. Alright, the next geometric definition we're going to look at is a segment. It's a straight geometric object without any width or thickness again, and it has the difference here, a starting point and an ending point. So it's kind of like a part of a line, so it doesn't go on forever in both directions. It actually has a starting and stopping point, and you can see here an example of a segment just in 3D space. It's just a piece of a line where it has a starting and ending place. Alright, a ray is, I guess we could say it's half of a line. It's a straight object without any width or thickness that begins at a point and extends forever in one direction. So, I mean, if you can kind of visualize that, that would be kind of like we start with a point and it would be half of a line where it continues to extend in one direction forever. Alright, after ray we can look at a plane. It's a flat geometric object with infinite length and width but no thickness, so it's infinitely thin. So you can envision basically a plane is basically a piece of paper almost, but the piece of paper is infinitely thin again, so it'd make it near impossible to see, but it would extend in both directions forever. So it would go out forever to the left and to the right, so it would just keep on extending infinitely in every direction until it reached infinity in all of its corners, and that would be a plane. Okay, next we're going to talk about a set of types of points. A set of 3 or more distinct points that could all be on the single line are called collinear. So when you put 3 points in this, I kind of drew these things over here to kind of help you see this. If 3 points all fall on the same straight line, those 3 points are said to be collinear. Coplanar is a set of 4 or more distinct points that could all exist on a single plane. So we're going back to the idea that we had the plane, and if you had at least 4 points all on this plane, those would be coplanar. But if you had a point that was off that plane, that would not be coplanar with the rest of these. And again, for collinear, that would be when we have three straight. Let me kind of make this line really quick here. If we had 3 points, and so these 3 points are collinear because all three of these are on the same line. Alright, an angle is a geometric object that could be described as two different rays emanating from the same starting place. So if we go back and we took another ray and we just had it extend in that direction forever and this direction forever, so it's two rays with the same starting place, so they go on forever, that creates what's called an angle right there. So that's an angle. We're just going through and carefully defining each of these things that you may have known before what they were, but now we want to talk about them more precisely. Alright, parallel lines are when we have parallel lines are two distinct lines that are in the same plane but never intersect. So that would be where we would have actually two lines, I'm going to just use segments for the moment, that are both in the same plane, and they kind of run together so that they would never intersect each other. So these two would be parallel, and maybe I can add arrows on the end of these. So you can see here basically if these two lines continued extending on forever and ever in either direction, because they're rising and running together going in the exact same direction, they would never intersect, and we'd refer to those as parallel lines. Okay, perpendicular lines are any two lines that form a right angle, meaning a 90-degree angle between the two. So if we went back and created another space in here and we drew two lines, and maybe I'll just draw a line right there and I'll put a point and I'll construct a perpendicular line. Do you see how these two always form 90-degree angles? Okay, so you can see between these two right here, if I drew an angle, it shows that it's a right angle, meaning that no matter how I move these, they'll always be exactly perpendicular, so that there's equal angles on either side of the two sides of the line where they intersect, or a 90 degree. If two lines meet in this way, they're said to be perpendicular. Alright, and the last type of lines we're going to talk about on here are called skew lines. These are kind of interesting. When it says skew, what that basically means is like this. We have two lines in three-dimensional space that don't intersect because they're not in the same plane. Like if you look at line K, it goes up and down, and M goes left and right here, and there's no way they'll intersect. They kind of miss each other. Like there's a space between them, but they're not in the same plane like parallel lines. So there are two types of lines we can talk about that don't intersect. Two lines in the same plane that don't intersect have to be parallel, but two lines in different planes would never intersect because they're not in the same plane, and we refer to those lines as skew lines. So this is an example. The blue line and the red line represent skew lines. And the last thing we're going to talk about is a geometric object that can be described as a set of all points in a plane that are equidistant from the common point, or is referred to as a circle. Let's look at this on a geometry sketchpad again. So if I took a segment that is always 3 centimeters and I kept it exactly that same distance out, and I kind of moved it slowly out away so it stayed 3 centimeters away, all of these points right here would perfectly form what's described as a circle. So you can see right here as I trace all the points out that are exactly 3 centimeters away, you generate what's called a circle, but it's in the same plane. Alright, so those are our first set of definitions, which we'll now see if we can apply and understand each of these definitions. Please take the time to make sure you copy these definitions down to assist you with the quiz later.